In the digitalization era, the LGM Group addresses the digital maintenance stakes by offering a complete set of tools and applications in order to optimize the support system. During a reconnaissance mission with 3 armored vehicles, the 3 vehicles were steering towards their target when a breakdown occurred on the 3rd vehicle. The success of the missions was then compromised by this unexpected technical failure. This type of situation can be critical during a very important mission. In this case, the grounding is due to a major failure of the suspension cylinder. The end of the mission could have been different thanks to the LGM Digital's digital maintenance solution. A well-led safety study would have shown that the cylinder's initial design did not meet the reliability requirements. LGM Digital would have suggested the engineering department to change the cylinder technology to meet the requirements. The suspension cylinder has been identified as a critical part of design. As such, it is particularly monitored by our integrated logistics support teams who ensure its traceability via the ELSA Logistics Support Analysis tool. The shock absorber has been identified as critical in the logistical tree, and thanks to our MOKA predictive maintenance solution, the analyst would recommend the monitoring of the shock absorber. This solution is based on a set of autonomous multi-measure plug-and-play sensors designed by LGM Ingénierie. For example, COSENS can monitor the vibrations, shocks, and temperatures the equipment is subjected to. COSENS is powered by a battery and is non-intrusive because it does not rely on the vehicle's onboard network. In the case of a normal on-road use, the shock absorber's potential is scarcely damaged because the shocks are moderate. The shock absorber's life potential is thus permanently recessed according to the data collected by the sensors. Each COSENS sensor transmits the collected data to the HubSense gateway in order to concentrate the information volume and ensure the pre-processing. Thanks to its modular design, HubSense can manage various telecom and network protocols such as Wi-Fi, 802.15.4 and LoRa. The processed data are transmitted to the central database developed by LGM. In a non-constrained environment, the data can be transmitted by a long-range network. In a constrained environment, the information transmission can be done once the vehicle has returned to the base via a secured communication protocol. The collected operational data are then analyzed by our MakeSense application. With our ForceSense application, it is possible to use the enriched information to visualize the potential of parts monitored by sensors. The deterioration of the shock absorber's potential is transmitted to the CINDI CAMM developed by LGM. A maintenance technical event is automatically generated. The maintainer receives a technical event warning and can directly open it on his touchscreen tablet. Thanks to the digitalization of maintenance operations completed by LGM Digital, the maintenance staff is assisted during troubleshooting and can quickly determine the origin of the failure. With a simple click, he can obtain all information necessary to the maintenance procedure. The maintainer can carry out the installation and removal of the shock absorber, following and validating step-by-step the operation mode on the touchscreen tablet. The maintenance staff is all the more efficient since they have been trained beforehand to the maintenance operation via virtual reality. Once restored, the shock absorber returns to full capacity. The maintenance procedure digitalization allows feedback, which is essential to the enhancement of predictive maintenance. The technical event closure is made through the automatic transmission of the intervention's electronic report to the CINDI CAMM. Thanks to the implementation of digital maintenance, the 3 vehicles go on a reconnaissance mission. This time, the vehicles will bring it to completion.